So good afternoon everyone. Welcome to lecture 14 of the course on data structure and algorithm. In the last class we have discussed the operation insertion at end on a doubly linked list, and today in today's lecture we will discuss about understand the operation insertion of any new node in any intermediate position in case of double linked list, and also in case of single linked list. And if time permits, then we shall discuss about delete operation both in single linked list and double linked list. So I'm sharing my screen. So hope all of you can see my screen. Is my screen visible to all of you?
Yes.
Okay. Okay. So first, let's bring a situation where the linked list contains at least two nodes. Intermediate position means okay, we do not want to consider the case where linked list is having exactly one node, that is the first node or last node. So at least two nodes we are taking into consideration. So that is your case number one. Okay, so suppose we have three nodes. Okay. So this is the linked list connection, double linked list connection, and let me give some values. Okay, so 5, 15, and 20, for example. Okay, and we want to, and this is your position number one, this is position number two, position number three. So there is no provision that we have to start the index count from zero. No, it's not an array, it's not linked list. So this position one, two, and three, and the indexing for the programmer and also indexing for the layman both are same in this case. Okay, now we want to ask the user to provide the data for the insertion and also the position where the user wants to insert that value. So two input information we want to have from the user. So let's start with the algorithm here, somewhere here. So the algorithm will start algorithm. So read, well, pause. Okay. Now then you want to call insert at mid. For example, this is the name of the function, and you want to pass on both the information val and pause. This is your function call. And somewhere in other place you are defining the function definition, and that is your insert at mid. Okay, so val pause. Right. So here we are starting the algorithm for the definition of the function insert at middle, not middle, any intermediate position. Okay. So now what you have to do, as you are going to insert a new node, that means you have to create a blank node, which we have already done, right? So temp is equal to address of new node. This is your step number one. Okay. Uh, so by doing this, what we are doing here, we are creating a blank node like this. Is my sound volume okay to all of you?
Yes, sir.
Yes, sir.
Okay, fine. So this is the blank node of which address, let's say its address is 2000, and it is being pointed by, we are doing this insertion at intermediate in the next lab, right? Okay. So this is your temp pointer, and it is holding the value 2000, right? That is the case. With the help of temp, I can access all the three insidious part or components of this blank new node, right? How can we can access this? So I can access this part using the syntax temp pointing brief. This is can be accessed by temp pointing data, and this can be accessed using the syntax temp pointing next, right? Okay. So next step, we have to insert, assign the value given by the user, that is val, inside the data part of the temp of this new node. So that means here I have to put the value of val. Whatever is the value, val. How can I do that? Using the syntax temp point. You already know that. So temp pointing data equal to val. Next, it's about, let me this magenta color key. What are the connections we have to establish? Achha, for that purpose, we have to understand, take an example, a typical value of pause in this case. So when you are exploring this case, linked list contains at least two nodes. Okay, so that means the size of the linked list is 1, 2, and 3. That is size equal to, or length of the list is equal to 3 in this case. Okay, but in general, this is the size of the list, right? So position value can be any value in the range. So pause may be any value within this range. One, it may be 1, it may be pause 1, pause 2, or pause 3. Anywhere user may want to insert. So pause may be equal to maybe lying in this range, 1 less than equal to pause, less than equal to size. So this should satisfy. User should not enter any other value other than this range, out of this range, right? And also you must go on, I mean apply this algorithm only if size is greater than equal to 2. Okay, so if size is greater than equal to 2, that means what? Linked list contains at least two nodes. So both the condition you are checking. So to satisfy this algorithm, okay, so size greater than equal to 2. If it is not greater than equal to 2, you will not perform this operation. You will ask the user, no, your operation can't be performed because this linked list have to be have to contain at minimum two nodes. So that is simple checking. If condition checking, that you have to check size greater than equal to 2. Otherwise, this is not possible. And also, if user provides any other value out of this range, you are again asking the user, no, your operation is not possible because you have entered some invalid position. That is not possible. Okay, fine. So let's say user has given a pause value. Let's say pause is equal to 2. That means here the user wants to insert. Okay, let's say pause 3. Pause 3. That means user wants to insert the value at this position. Means after the insertion successful done, okay, the value should be, the linked list should be like this: 5, 15, then val, then 20. That is the meaning of insertion. After insertion, this element node should be present at this desired position 3, and it will go to the 4th position. That is the case. Now let's consider this example where user has given pos equal to 3. Now what are the connections we have to establish, okay, in this situation? So what is this connection? Question mark. What is this connection? Question mark. What will be this connection should be modified because this should point towards this. Okay. Also, this connection should be modified. Okay. This much. Okay. So after the successful insertion of this node, what will be the connections? I'm just showing you what should be the connections. The connection should be, this should point towards this node, this should point towards this node, okay, and this connection should be broken, and this connection should be done, this connection should be broken, and it should point towards this node. So these are the 4 connections. Okay, these 4 connections you have to establish. That's all. And those 4 steps you have to write over here using proper syntax. So let me sequentially which connection should be done first sequentially. Let's do it again. So first of all, I think this connection should be done, number 1. Then this connection should be done, okay, number 2. Then this connection should be done, 3. And then this connection should be done, 4. So number 1, number 2. So accordingly, you write over here, very easy. Now, before that, I have to access this content. You have understood what should be the content. You have to modify it. Now, what is this new node? The node immediately left to this position where you are going to insert this new node. So this is like, if this is the pos position where you are going to insert, so this is pos -1. This is situated at pos -1. Someone should reach to this position with index pos -1 and point towards it, right?
Hello, sir.
I need a traversal pointer. So tr. So tr is supposed to reach this pos -1 positioned linked list node, right? So I need a while loop to put a condition over there, okay, and write and do to traverse the tr pointer, tr equal to tr pointing next, okay, end y. Okay, okay, end y. So now condition is okay, you may, as you know, how many times you have to shift the tr pointer. Initially, tr pointer is pointing towards this, and you have to reach this position. So how can I do that? So I can count the number of shifts to be applied on tr pointer. So better you can use in that case 4. Okay. 4. So for I equal to, let's say 1, 2, I don't know what you will write in steps of, by default it's in steps of 1, 2. Okay. Now this is the interesting thing, the most important conceptual part of the algorithm, is how many shifts we have to apply. In terms of pos, we have to get the answer, the formulation. Okay. Fine. So to make you understand this, suppose this is the first node, second node, third node, fourth node, fifth node, and sixth node. position number 1, 2, 3, 4, 5, and then 6. And you have a new node and you are going to insert these at, let's say, position number 4 you are going to insert, means here. Okay, and initially TR pointer is pointing towards this node, and this is your pause. Position. This is your pause minus 1 position, and this is your size position. Position index equal to size. Total number of nodes is 6, size equal to 6. Now initially TR is pointing towards this, right? Okay. So you have to, if you perform one right shift on TR, so TR will reach by one shift, it will reach to this position. So how many shifts you have applied? One, shift number 1. Then you are shifting further the TR to this position. This is shift number 2. Okay, and that is your case. You have to bring the TR pointer at pause minus 1 position by applying 2 shifts. Whereas you are going to insert the new node at position index, pause. So if pause equal to 4, then pause minus 1 equal to 3. And how many shifts you are applying? That is 2. This is the pattern you have to observe. Okay, so let's say I want to insert the new node at position number 5, for example. That means here at this position. Okay, so in that case, this is your pause. Okay, and this is your pause minus 1, right? And then you are right shifting TR again to this, and this is your shift number 1. This is shift number 1, this is shift number 2, this is shift number 3. So how many shifts you have applied? 3. And how it is related to pause? In this case, pause equal to 5, pause minus 1 equal to 4, and you have applied 3 shifts. So what is the pattern then? What is the formulation? If you are going to insert a node at position pause, you have to make TR pointer to reach position index pause minus 1 by applying pause minus 2 number of shifts. 3 means 5 minus 2. Yes or no? Yes or no?
Yes.
Should I check it with another example? Let's say 6. Not very prompt answer from your side. Suppose we want to insert that position in new node at position number 6 here. So then, what is your pause value? Your pause value is then 6. Where you want to insert, this is your pause. And what is your pause minus 1? This 5. Okay. Pause minus 1 equal to 5. Sorry. Pause minus 1 equal to 5, and pause equal to, in this case, 6. Okay. Then where TR has to reach? TR has to reach this position. How many shifts in that case you are applying? 4. Right? And how that 4 is coming in terms of pause? If pause equal to 6, then this should be 4. This should be 5. So always, if you want to insert a new element at index pause, you have to make TR to reach the node with index at position pause minus 1 by applying pause minus 2 number of shifts. So if you are applying pause minus 2 number of shifts, you have to execute that for loop, that pos minus 1, pos minus 2 number of times. So here we are writing pos minus 2, and that is the reason why we are doing this. Okay, everything is very logical, nothing is just blind. Okay. So for I equal to 1 to pos minus 2, that means in code it should be I equal to 1 semicolon I less than equal to pos minus 2 semicolon I plus plus. That's it. So do tr equal to tr pointing next. So by doing so, we are making tr enable to reach the desired position, where in this case tr is sorry, tr has reached this position. Okay, tr has reached this position. You are going to insert the new node at this position. Okay, so now I can access this next pointer with the help of tr pointing next. Okay, and similarly, can you tell me? Okay, sequentially. Number one connection is this connection. What is this? I should assign the address. Okay, let me write over here. You tell me one by one. Step 1. Okay, then step 2. I think all of you can answer this. No issue. Step 3. Then step 4. These 4 steps are those 4 connections. Okay, so first connection, this content should be equal to this content. No, not this content, sorry. Yeah. This should be pointing towards this node. Means this content should hold the address of this node. Okay. So I'm writing here that, so the pref pointer, this is the pref pointer of this node, of temp node. So pref pointer of temp should be equal to address of node at pos minus 1. So tell me what is the code? How should I write it? Anyone?
Temp pointing prev equals to tr.
Temp pointing
Prev is equals to tr.
Prev equal to address of node at pos minus 1. This is pos minus 1. And this is pos tr. Exactly. So this is your tr. Okay. Okay. So next line. Connection number 2. Connection number 2.
So temp pointing next is equals to tr pointing next.
Exactly. Good. So this address can be accessed by tr. If this is tr, the tr pointing next means address of this node. Very good. So this is temp pointing next equal to tr pointing next. Next step number 3. This connection.
Tr pointing next is equal to temp.
Tr pointing next equal to temp. Very good. Okay, and then step number 4. This should be equal to the address of this node. This should be equal to temp. So how can I access this? This connection was lost, but this is not yet lost.
So tr to next to next.
Tr to next means this. To next means no, wrong.
So
Next
Tr
means
to
this.
next cut to brief.
Tr pointing next
Yeah,
pointing
yes.
next to temp.
Hello?
Pointing next or
Hello?
tr pointing next
Pointing press
I'm not
We are
getting it.
pointing next, pointing pref.
Anyone.
Sir, temp pointing next pointing to
So already you did this connection. There are two ways in which we can access this. One is using temp, other is using tr. So
So
if you want
temp
to use
pointing
temp,
next, pointing pref.
yeah, the temp pointing next, pointing pref, or using tr pointing next, pointing pref. But that is not possible because tr pointing next has already have been modified. So only choice is temp. Temp pointing next means this node, pointing pref means this pointer. So tr, again this algorithm will have some limitation. Tr pointing next, pointing pref should be equal to temp. Okay, so let me check once. Tr
So
has,
temp pointing na?
huh?
temp pointing
Sorry,
next.
temp pointing.
Pointing.
Temp pointing next. একবার দেখে নিই tr, so then this connection is lost. So temp pointing next is okay. ঠিক আছে. Okay, so again, yes, this algorithm you have to verify wherever you are trying to insert, okay, at the end or at the beginning. ঠিক আছে? Because this null connection have to be re-verified whether this algorithm is working very fine or not. So this is the typical test case where we have written the algorithm. ঠিক আছে? Okay, so this is done. So similarly, we can do the insertion at intermediate position in case of single linked list. So let's have a look on that. Okay. Insertion at intermediate position in singly linked list we are doing now. So let's take okay, we have to take a different picture. So let's take a same case where at least two nodes are present in the list. Okay. Okay. Okay, let's say this is 5, this is 10, this is 20, 15, and this is 25. Okay, this is pointing towards this node, this is pointing towards this node, this is pointing towards this node, and this is pointing towards null.
স্যার
Yes.
আচ্ছা স্যার একটা আমার ডাউট ছিল ওই কানেকশনগুলো যে করলেন আপনি মানে প্রত্যেকটা নোটসের মাঝখানে ওখানে যদি স্যার থার্ড কানেকশন আর ফোর্থ কানেকশনটার মানে স্যার আমরা যদি অর্ডারটা জাস্ট খালি যদি ইন্টারচেঞ্জ করি মানে স্যার অর্ডার মানে ফোর্থটা আগে করলাম থার্ডটা পরে করলাম
হ্যাঁ, করতে পারো।
দেন স্যার ওটা কি মানে কিছু কি মানে কিছু কি এফেক্ট কি পড়বে মানে
না, দেখো তুমি আগে ফোর্থ কানেকশনটা আগে করছো, সো তুমি দুইটা আগে করে ফেলেছো। দুই যখন তুমি
স্যার
করে
ওয়ান টু তো হ্যাঁ স্যার ওয়ান আর টু তো স্যার ঠিক আছে আমি স্যার থ্রি ফোরটা
যেই
বলছি
তুমি
জাস্ট
দুই
অনলি
করে
থ্রি
ফেলেছো তখন তুমি টেম্পের থ্রু দিয়ে এই নোটটাকে অ্যাক্সেস করতে পারছো।
ইয়ে স্যার টেম্প পয়েন্টিং নেক্সট পয়েন্টিং প্রেস করলেই স্যার পেয়ে যাবো
হ্যাঁ, ঠিক আছে, ওটা
Yes,
তুমি
sir.
আগে করে দিলে তারপর তুমি তিনটা করতে পারো, অসুবিধা নেই।
আচ্ছা আচ্ছা ঠিক আছে ঠিক আছে
Okay, so then হচ্ছে তোমার this is the situation, we want to insert a new node and same set of algorithm you will have. So I'm just pasting this. Okay. Same logic, the less number of connections we have to establish over here. Okay, fine. So algorithm, read val position, insert at mid val okay, okay, coming to this. So temp equal to address of new node. So temp is pointing towards this node. Okay, and is holding some address, let's say 2000. Okay? So I'm not writing here, the address of this node is 200. So next, temp pointing data equal to val. Oh, sorry, my mistake. A new node, blank new node. And it is being pointed by temp. Okay, and it is holding the address, let's say 2000. The address of this is 2000. And temp pointing data equal to val. So val is stored here. Next, for I equal to 1 to pos minus 2. So if you are trying to insert, let's say this node at pos equal to 3, means at this position. So then you have to reach TR at this position. And that is absolutely fine with this for loop, same logic. Okay, so by this, TR is pointing towards this node. Okay, ঠিক আছে? So next, what we are doing, temp pointing prev equal to TR. Temp pointing prev equal to TR means temp pointing prev. So that is not applicable. So okay, let me show you what are the connections we have to do in pink color. So this pointer is going to be inserted at this third position. So this should point towards this. And this connection should be broken so that this is pointing towards this. That's all. You are done. Okay, so these are the two only connections you have to establish. So this is 1 and then this is 2. So first connection is temp pointing next. Temp pointing next is equal to what? Tell me.
TR
TR
pointing next.
pointing next.
TR pointing next. This should be occurring first. We can't alter the order 1 and 2. It will matter. First, this connection will be done, then only the second connection should be done. Otherwise, it will be a problem. So then in step 2, so this is bolo ki hobe? Connection number 2.
So temp pointing prev equals to TR.
No.
Sir,
There is
TR
no
pointing.
prev.
TR pointing next equals
Pointing
to
next equal to
temp.
temp.
TR pointing next means this
Equals to
content
temp.
should be equal to the address
Equal
of
to
this
temp.
node, means temp. And that's all. These are the two connections which you have to do. Okay, so very easy. This is the algorithm for the case when the linked list contains exactly 2 nodes. At least 2 nodes, not exactly. Okay. So it's already 1:30. So I will not extend this lecture further. So let's discuss delete in the next class. Okay. So just I just want to tell you the logic, and you will do the algorithm on your own. So far we have been very slow in this course. We have understood the logic, then we have understood how to write the algorithm, how to develop the algorithm. Algorithm development is very important. Once you develop the algorithm very properly, verifying or satisfying all the possible test cases, case 1, case 2, I have shown only one case where it is containing at least 2 nodes. And also in case of having at least 2 nodes, I have only demonstrated the logic for position lying in the range 2 to size minus 1. So what will happen if user wants to insert at pos 1 or user wants to insert at the end position, not at the end, actually at position equal to size. So in that case, is this algorithm working very fine or some fine tuning you have to do? So these two verification is pending, you have to do. Okay. So I'm doing this as a home task. So verify these algorithms insertion at any intermediate position what we have done today. Okay, with pause equal to 1 and with pause equal to size. ঠিক আছে? If it is okay, then fine. If it is not okay, do the appropriate fine tuning connections adjustments. Okay, and one thing I just want to mention over here, it's a big note that insertion at end position is not same as insertion at end. Okay. Okay, so next, coming to the logic of delete operation, just logic, not algorithm. Delete operation, just let me show you the connection. Delete operation in DLL, doubly linked list. Okay, so let's say there are few nodes already present over here. Okay, okay, so this is the connection, double linked list situation, and you want to insert a delete and elements. Let's say we want to delete this. Okay, so then the modified connections should be, okay, so this should be altered, this content should be modified, this is deleted, right? So I'm not bothered about it. What are the contents you are changing? And this should be modified. This too. ঠিক আছে? So this should point towards this. So this is broken. ঠিক আছে? And this is pointing towards this. So first this is 1 and then it is 2. Okay, then this connection will be lost. So if you do this, let me delete this. This is lost and this is lost. And then third step, you are doing free of this node. You are deallocating memory for this node. So then this will not be in the picture. And tell me, is this the desired result after deletion of that node? Yes or no?
Yes.
That's all. Okay, so this is the delete operation in double linked list. Yes. Okay. Now in case of single linked list, Okay. Suppose we want to delete this. So new connection should be just this. Just this connection, one. And then delete. So if you do this connection, automatically this will be lost. And if you delete this node means this is gone. And along with this, its connection will be also gone. Already this is deleted. And this is the desired situation. Yes or no?
Yes.
Yes, sir.
Very easy. Delete. Okay. So write the algorithm for delete operation in single linked list and double linked list and show to me, because in the next lab session, Tuesday and Thursday, you know that you have to perform insertion at beginning, delete operation in single linked list, double linked list, and also the inversion. Okay, I forgot to mention about the inversion. So in double linked list, inversion is very easy. It's a very easy to do the traversal double linked list. So we have already the picture of double linked list, right? This is the picture of the double linked list. Okay. Okay. I think this is good. So if, let's say, we assign some values, 1, 2, 3, here 4, and here 5. So I want to display 5, then 4, then 3, then 2, then 1, right? Okay, reversing the list or inverting of the list. So first I need to use a pointer to point towards the last node. Let's say TR is the pointer which is pointing towards this last node. Okay, so TR is the pointer which is pointing towards last node. So let me, I think it will be better if I copy this entire picture. Delete the connections. Okay. Okay, so first of all, the TR is pointing towards the last pointer. Okay, this pointer. And with the help of TR, you are displaying the content, the data part using TR pointing data. You know what is the syntax? The simple TR pointing data. You are displaying TR pointing data in printf, through printf. So when TR is pointing towards this, you are just simply displaying TR pointing data. Then you want to make TR pointing to left shift one amount so that it is pointing towards this. How is it possible? Is it possible here? Tell me.
TR is equal to TR to play.
So if I want to do that, what should I do? TR equal to TR pointing, what?
Pref.
Pref, exactly. Okay, TR pointing pref. This is TR pointing pref, and it is holding the address of the previous node. And then again I am doing TR pointing data. Again I am doing TR pointing data. This content. So first 5 what was displayed, now 4 is displayed. Then again what I want TR equal to TR pointing pref. So now TR will be pointing towards this node. TR pointing pref means this. What is that thing? Address of this node. So TR equal to holding this address, right? And again I am doing TR pointing data. So 3 is displayed. Then TR equal to TR pointing pref. This is TR pointing pref at this situation. This is holding the address of this node that is replacing the value of TR. So now TR is pointing towards this. And with the help of TR pointing data, we are able to display 2. We are able to display 2. Next, again TR equal to TR pointing pref. With this, TR is pointing towards this. And then TR pointing data display 1. And then TR equal to TR pointing pref. What is this? Null. So if I stop, if I reach the position where TR is pointing towards null, I will stop. So this is the loop, right? So this loop should be continuing. So loop is continued till tr equal to null. Okay. So this is the inversion operation in case of doubly linked list. Inversion in doubly linked list. Okay. Now the major important challenge is inversion in single linked list. Inversion in non of it. Inversion of single linked list. এখানে পিকচারটা কেমন? ওই পিকচারটাকে আবার নিয়ে আসি, এই পিকচারটাকে yeah. So this is inversion of SLL. How can we do that? So this is the picture, right? Now first I have to point towards this point by a pointer, let's say TR. And with the help of TR pointing data, I will be successfully able to display its content. Okay, display equal to 5. Okay, then I want TR to point towards this. How is this possible in case of single linked list? Tell me. Any idea?
Sir, can we take another pointer?
Okay, interesting. So let's say rename this pointer name. This is, let's say, car, and let's say we are taking another pointer, let's say prev. Now tell me, so before this, what should I do? So I am initializing car. I'm initializing car by pointing towards this last node. And what should I do with the prev? On another pointer. Let's say its name is prev. Then what should you do with this pointer?
ফার্স্টে তো লাস্টে পৌঁছাতে হবে আমাদের কারেন্টটা দিয়ে।
ওটা তো করে দিয়েছি, লাস্টে পৌঁছে গেছি, মনে করো পৌঁছে গেছি। হ্যাঁ, তারপর কি?
বারবার প্রিফটাকে কারেন্টে অ্যাসাইন করে করে যদি যাওয়া যায়।
আমার একটা কথা মনে পড়ে গেল, মাইকেল জ্যাকসনের মুন ওয়াক। Okay, so it's like that situation, you will feel it. So I think this should point towards this. One foot is here, another foot is here. ঠিক আছে? So এবার তুমি একটা একটা করে পিছিয়ে যাবে। এই যখনই এখানে আসবে তখন যেন এই এখানে চলে আসে, আবার এই যখন এখানে আসবে, সরি, তারপর এই যখন এখানে আসবে তখন সেই যেন এখানে চলে আসে। So it's like Michael Jackson moonwalk, right?
Yes, sir.
সেম স্টেপ। যদি কেউ করেছো জানো, মুনওয়াক কেউ জানো?
হ্যাঁ স্যার জানি,
যারা ডান্স
করিনি তবে জানি।
Okay. Anyone? Okay, no problem. So this is the situation. Car is pointing towards this last node, prev is pointing towards this node. Okay. So with the help of this car pointing data, I am displaying the content 5. Okay. Then what should I do? Okay. If I do this, then this is possible. Car equal to, this is pointing towards this. Now again the challenge is, how can I make this pointer brief to point towards this, where I do not have any other pointer. With the help of brief pointer, I am able to point this car pointer to point towards its previous node. And what about this? Okay,
আরেকটা পয়েন্টটা নিতে হবে কি?
তাহলে প্রত্যেকটা নোডের জন্য একটা করে পয়েন্টার নিতে হবে, তাই না? This is really challenging, I guess, very important and thought provoking. Okay, so already 146. Okay, so I think this is a fresh problem. So it will take some time to come up to the logic, to make you understand about the logic. So let's, I mean, reserve this for another, for the next lecture. It will hardly take 15 minutes max. Okay. So my suggestion is, we have already done discussion today, a lot of topic, that is to brief with this. Let me brief the lecture class. So in today's lecture we have understood, discussed the logic of insertion at any intermediate position in doubly linked list, with the condition linked list contains at least two nodes. We did the algorithm development, and then we have done algorithm development of the operation insertion at intermediate position in case of single linked list, with the case linked list contains at least two nodes. Then we have done the logic part of delete operation in case of double linked list, and we understood delete operation in case of single linked list, and we understood inversion of double linked list. Okay, so your home task says the algorithm development for inversion of double linked list, delete operation in single linked list, delete operation in double linked list. These three. Okay, so see you in the next class. Thank you for listening to the lecture. Okay, so I'm stopping my presentation, and we shall have a very short quiz, 5 questions. So the 4 minutes, I'm pasting the link on the chat box. This I pasted on the chat box. Okay.